There's a thread going on right now on the Galaxy's Edge Discord server talking about, wouldn't it be nice if you could have your legacy lightsaber that outputs a red blade, modify it in a way that makes it blue. And that's what I'm going to do. I have a Ventress hilt here, and I turn it on, and the light's not helping me at all here, but you can see it's a red blade. And what I am going to do now is modify this otherwise stock blade and make it so it outputs blue instead of red. And I'm going to do that in a way that I haven't done before. So that's why I want to make this video. Just because it's a slightly different way to modify the blade. Inside the blade, there are 3 transistors, one for each color, red, green, and blue. And there's a control signal that turns each transistor on and off. When the transistor is on, electricity can flow through it, completing a connection to ground, allowing electricity to flow through the LEDs in the blade. In the past, what I've done is when I'm doing color mods, I'll take, the power connects from that comes through the LEDs and out the LEDs into a transistor. And that point where it connects between the LEDs and the transistor, that's the point that I would start, cross-wiring things to get different colors. But this time, for this mod, I want to modify the control wire, or the control wires, the gate of the transistors. I want to cross those signals and see how that mod works. It's going to be maybe a little bit more difficult, but let's see how it goes. So I have the blade controller exposed here. Let's take a quick peek at what's going on. So down the bottom here we have 3 transistors. They are labeled A to H. Those are N-channel MOSFETs. And the way it works is you have your red, green, and blue channels here. They come down into these transistors. These transistors, when they get turned on, connect through to ground, enabling electricity to flow out through the blade and back through to ground, completing a circuit, turning the LEDs on, etc., etc. These 3 transistors, I believe, are red, green, and blue. So if we swap the gate pin on red with blue and vice versa, when a command is sent to turn on the red channel, it'll actually turn on the blue channel. So which pin is which? Which one is the gate that we have to deal with? MOSFETs have 3 pins. The gate, the source, and the drain. Source is going to connect to ground. The drain is what's going to connect to the negative side of the LEDs in the blade here. And then the gate is what controls turning that transistor on and off. And the gate pin is this one right here on all 3 of these transistors. And then the drain is up here, and then the source is over here. So I need to lift or remove this transistor and this transistor, and then run a wire from here, from the pad that's going to be here, to the pin on this transistor here, and vice versa. And I'm going to need to lift those pins so that they're not making any kind of electrical connection with the pad that they will have formally, they are right now, but will be disconnected from. Which means I'm going to probably have to pull the whole transistor off and resolder it at an angle, putting some space between the pin and the pad so I have room for wire to connect to the pad underneath it. And it'll also give me the opportunity to solder a separate wire to the pin itself. And I'll probably put some Captain tape over those pads once I've got the wires connected up to them, to provide a little layer of insulation to help make sure that there's no electrical connection there, because I'm trying to break that electrical connection. And assuming all of that goes well, I'll have a couple of wires here. I'll just fold them in over the middle here. There's plenty of space inside of the blade base to run that wire, so there's no problems with this getting in the way of anything. And put it all back together, and we should get a blue blade instead of a red. So I think it's time to turn on the soldering iron and get to work. So I've got the camera at a slightly odd angle here just to try and get it somewhat out of my way here as I go to work. I've also got a ceramic tile, cost $1 at the hardware store, underneath it just to provide a little support so I can press down with my soldering iron and I'm not bending the PCB here and risk breaking it. One thing I think I need to do is I'm going to take a little electrical tape here and I'm just going to tape the board down just to temporarily keep it from moving around while I'm working here. So it's going to be like that. And so now I need to remove these transistors. And the way I think I'm going to do that is I'm going to try flooding the entire area with solder. I'll start with this one. And it's going to take a minute for the pins to heat up so they take the solder. Good. I'm just going to make a big blob of solder on that side. And then come on the opposite side. And you'll notice my hands are especially shaky because I've just had a bunch of coffee. But that's okay. We can still get through this. Heat up both sides and just scrape it off. There we go. Good. Good. So I'm just going to put that off to the side for the moment. I'll have to clean that solder. There's a big solder blob on there. I'll have to clean that off, but that's okay. We can see a bunch of solder blobs on the PCB as well. I can get some of that off just by grabbing it with the iron, like so. And I will clean off those pads in a moment, but first I want to get the other transistor here. They're the same transistor for all three of them, so you don't have to worry about mixing them up if you put the red transistor where the blue transistor was, or vice versa, whatever. It's fine. You're not going to hurt anything because it's the same transistor. They do the same job. Okay, so I want a blob there. A big blob there. Heat them both at the same time. There we go. Get that transistor off. Good. To clean the pads, I'm going to be using some solder wick, which is just this copper braid that acts like a sponge for solder. So what I can do is come over here, and I'm just going to reheat the pads real quick. If they're a little warm, it helps the solder wick. And it just sucks it right up like a sponge. And now you got clean pads. So I'll come over here and do the same for this side. Good. But first I need to take care of quickly getting the solder off of these transistors. So I'm just going to bring my iron over the pins, and the solder will want to stick to the iron more than the pins. So that's got that one cleaned, and it's sticking, because it's covered in flux, it's sticking to my tweezers. So just going to help get it off the end of the tweezers. Grab the other transistor that does not have as much solder on it, but I still want to get that little ball of solder off. Again, bring my iron in, and it comes right off. So now I can put those off to the side for the moment. Okay, so those two transistors are lifted. Now I want to grab wire, and I want to run a length of wire from the gate pads, which are these pads here. Run that off to the side, and I'll reconnect them, the other end of those wires, later on. For wire, I'm just using some 30 gauge wire that I bought off of Amazon. It comes in a bunch of different colors. It doesn't really matter. The control, or I should say the gate pin on these transistors will not be carrying much current. I suppose I should do red and blue, shouldn't I? There's not going to be a lot of current going through these, so really you don't need a very heavy gauge wire. You could get away with like 40 gauge magnet wire if you wanted to. It's really not going to matter. I'm going to purposely cut this wire long because I can shorten it later. I can't make it longer later if I need to. So cut the wire long early is a not terrible approach to cutting wire for any of these projects. I'm just going to strip the end of the wire just a little bit. I don't want to expose too much wire because the amount of wire you have exposed increases your risk of creating some kind of inadvertent short somewhere or connection that you don't want to make. So what I'll do now is I'll tin the wires just a little bit. That means taking some solder and just coating the end of the wire with a bit of solder, like so. That does a couple of things. It's stranded wire, so the strands are going to want to spread apart. So doing this sort of helps keep them together. The other thing is that when you go to solder them, because they have a little coating of solder on them already, they will make a connection more quickly and more easily than if the wire had no solder on it to begin with. Next is I need to connect these wires. So that's the red, that's the blue control signal. So what I want to do, which wire do I want to go where? Okay. Little blob there. Grab the red wire and just make a connection. Good. Now we do the blue. Same deal. All right, good. Now I need to put the transistors back. Okay, I have cleaned the area with some isopropyl alcohol. I have some Captain tape, and I'm going to try, and I want to cover the exposed joint here, but I don't want to cover the pad nearby, and I don't know how well this is going to go, to be perfectly honest. I'm just looking to create a little bit of insulation here. I just, to prevent any accidental shorts or anything. Because I'm going to have these transistors, when I put them back, kind of at a weird angle, and it's going to be a little risky. So we'll see how this goes. I'm also thinking I should have done the blue transistor completely before I started in on the red, and I shouldn't be doing these wires together, but oh well. And of course the tape wants to stick to the tweezers and not the board. Captain tape you can get online on Amazon and other places. It comes in rolls. It's not expensive or hard to find, and I just cut it up into very tiny squares with like a hobby knife on my cutting mat here. Okay, transistor time. This'll be interesting. This is something I've never done before. What I might do is start with the red one first, and I think what I'm going to do is put an oversized blob there. And try and get a good angle, a good grip on the transistor. I have no idea how this is going to go. It's close. It's close to what I want, but I'm sort of realizing that that my idea is not great. Okay, this is going to be a bit more fidgety than I had intended. So the transistor, which is coated in flux, here it is. The pin on the left here is the pin that I want to disconnect from where it's supposed to go and wire it off to another pad. I want to bend that pin up. I need to give myself some more room here. So I'm going to try grabbing it with one pair of tweezers and come in with the other and grab that pin and lift it. And how well does that look? It's a little bit lifted. Maybe I can lift it further. I'm getting to the point, though, where I risk just straight up breaking the transistor completely. I mean, that's given me maybe... I mean, it looks like a mess because it's covered in flux, but that pin's lifted. So the pin on the left has been lifted up a little bit. I think I need to lift or pull the pin on the right down. Bring it down a little bit more than it was. So that way when I tilt this thing over, it's closer to the pad. Otherwise, if it's not near the pad, I can't form a connection. I think that's going to be it. There was a big blob of solder there. I'm trying to reduce it. I don't want to bridge to the pin next to it. I think we're good. I think we're good. And then I would just attach the blue wire, and maybe it'll work. Maybe. Quick continuity check. Good. No bridge. Okay, good. And that connects to source, right? So, good. Okay, I feel pretty good about that. I don't know, that might be enough. There's a gap on the drain pin here, or the source pin, I mean. And if I put a big blob of solder, I can probably get that gap taken care of. Remove the excess with my iron. Okay, let me give you a close-up look at what those connections look like right now. Okay, so here are the transistors. You can see they are up at an angle now. You can see there is a gap between the pad beneath them and the wire and Kapton tape. And that is how it's going to have to be. All right. So now it's just a matter of connecting this wire here and the red wire over here, and we'll be ready to test. Okay, I want to give myself some room, so I'm going to cut the wire a little long. That's fine. And I want to strip just a little bit off. Good enough. This wire uses silicone for its insulation, and that it's really chewy insulation, so it's very easy to strip the wire with just a pair of side cutters. No special tool necessary. You just sort of grab onto the insulation and pull, and it tears itself. Okay, I'm just going to come in here and do my pre-tin on the wire. Good. I'm going to snip the wire now. Okay. Now I want to try and also pre-tin the leads on the MOSFETs here. Okay. All right, that looks like a connection. Okay, that's that's it. Yeah, that might do it. All right, so there's the completed mod. You can see the blue wire comes off and goes over to this transistor. The red wire loops around back over to the other transistor. There's a gap between them. There's a little bit of Kapton tape. In fact, I could probably slip a little more Kapton tape in there now. But I think we're good. So, reassembly now. Let's see how well this works. I need to put that through like so. That goes on top, making sure that there's no wire sticking out here, getting, pinched. That went right together without any force. Good. Okay. I'm just making sure that the end here is lined up correctly. It's key that you can, as you're pushing this back together, stick your finger in here and, sort of rotate it. Try to torque the end connector here a little bit. You could probably use your tweezers too if they're big enough. And it'll snap into place. So you've got a good alignment. If this isn't lined up right, if it's off even a little bit, you're not going to make a connection with the blade connector, and your blade's not going to work. I'm not going to screw this in yet. I'm just going to plug this into the hilt as is. I'm not even going to cut away, so we can prove Okay, if this worked, we're going to get a blue blade. Here we go. Hey, look at that. It's like I know what I'm doing. Believe me, I'm just as surprised it worked as you are. So the blade is back together. I've screwed everything back. I pulled out my Kylo Ren. And yeah, it works here as well. You even get the flicker effect, but now in blue instead of red, which is kind of neat. So there's one more thing I just want to mention here at the end of the video. So you saw those MOSFETs, those little tiny 3-pin things. And they have a gate, a source, and a drain pin. And the gate pin is what I swapped on the red and blue transistors. I could have done the same mod, but using the drain pins, which is if you have 3 pins here on a transistor, right? This top pin is going to be the drain in your blade. That would have been easier because you could just apply the soldering iron across the 2 bottom ones and lifted the top one up a little bit. I've done that technique before in other blade mod videos that you can look in the videos on this channel. I just went with the gate for this mod just because it's different. I haven't done that particular mod before, and I wanted to see how feasible it was, and it's a bit more finicky, but it'll work. So you don't necessarily need to go through all the extra trouble I went through. There's a slightly easier way to do it, and that is lifting the drain pins and swapping the drain pins instead of the gate pins like I did in this video. But other than that, I think that's all that needs to be said. Good luck. Have fun.